2.2.5 Test Automation, Unit, Integration, Regression. In the previous chapters, our pipeline learned to move code safely, but pipelines don't guarantee quality by themselves. They only guarantee movement. So at some point, every mature team asks the same question. How do we know, truly know, that our system still works after each change? That's where automated testing becomes more than a checkbox. It becomes the nervous system of the pipeline. Because CI/CD without tests isn't modern engineering, it's automated risk. To see how this works in practice, let's start with the smallest kind of automated check, the unit test. Everything in testing begins at the smallest possible level. I once worked with a fintech team that learned this lesson the hard way. They had a simple question that nobody had ever tested directly. What happens if someone tries to refund the same transaction twice? In production, that scenario actually occurred, and the system behaved badly because nobody had imagined it clearly enough. So the team did what good teams eventually do. They sat down, opened their test framework, in their case it was Junit, and they created a tiny automated check that simulated that exact situation. From that moment on, every time someone changed the payment code, the pipeline replayed that scenario automatically. If the logic ever drifted back into dangerous territory, the test would catch it immediately. Teams use different frameworks for this. Junit, PyTest, Jest, Nunit. The names change, but the idea stays the same. These kinds of tests don't care about networks or databases or complicated environments. They focus on one very small piece of logic and ask a very precise question. When this piece of code receives this situation, does it behave exactly the way we expect? They run fast. They run right after the build, and when they fail, the message is clear enough that the developer can say, "Okay, the problem is right here." No guessing. No detective work across the entire system. Over time, these small tests start to feel like guardrails on a highway. Most days, you hardly notice them. But when something unexpected happens, they are the quiet reason the car never leaves the road. But checking small pieces in isolation is only part of the truth. Real systems live where pieces meet. I remember an e-commerce startup where everything looked perfect inside the pipeline. All the unit tests were green, developers were confident, and yet real customers couldn't complete a checkout. Individually, every component behaved correctly. Together, they fell apart. The root cause turned out to be almost embarrassing. Two different services disagreed about the name of one data field. One called it total, the other expected amount. No unit test could have seen that because each service was tested alone. So the team added a different kind of test, integration testing. Instead of testing functions one by one, they used tools like Postman and Supertest to simulate the entire journey of an order. They triggered a request as if a real customer were buying something, watched it travel through the order service, pass into the payment service, and finally reach the inventory system. And the question was no longer, does this individual function behave correctly? The new question was, when this whole flow runs from beginning to end, does the story actually succeed? From that day on, every commit automatically triggered those integration checks in the CI pipeline. If two services ever drifted out of sync again, the pipeline would catch it long before customers noticed. Different teams choose different tools: Postman, Supertest, WireMock, even temporary environments created with Docker Compose. But the principle is the same. You let services talk to each other in a controlled setting, and you watch whether they truly understand one another. Integration tests sometimes add a little bit of time to the pipeline, but the extra seconds they cost are nothing compared to the nights they save. They slow you down only as much as a seatbelt does, just long enough to make sure you're safe. And nobody argues that a seatbelt is unnecessary. There's another kind of testing that teams only truly appreciate after they've been burned by it once: regression testing. The most painful bugs are not the new ones. They are the ones that used to be solved and quietly come back. A large SaaS team discovered this when a brand new feature accidentally broke something completely unrelated: the password reset process. Nothing crashed, nothing screamed, it just quietly stopped working, and nobody noticed until support tickets started piling up. So the team decided to never let that happen again. They built what is called a regression suite, a set of automated scenarios that replay the most important user journeys again and again. Every time the pipeline prepared a new version, those scenarios would run automatically. They would log in, reset a password, renew a subscription, delete an account, all without a single human touching the keyboard. To make this possible, the team used tools designed to pretend to be real users in a browser. Selenium, Cypress, Playwright, different tools, same idea. They click where a user would click, type where a user would type, and expect the application to respond the same way it always has. Weeks later, someone changed a harmless-looking button label in the interface. The regression suite noticed instantly. A single scenario failed, the pipeline stopped, and the team fixed the issue before it ever reached a single customer. Nobody outside the team even knew there had been a risk. Regression testing is not flashy. It doesn't produce exciting demos. It simply asks one quiet but powerful question: everything that worked yesterday, does it still work today? And in production systems, that question is priceless. At this point, some teams ask a natural question: why can't we just do all this manually? Click around the staging environment, follow a checklist, and call it done. And the truth is, many teams tried exactly that. They clicked, they checked, they meant well, but they were tired on Fridays. They rushed during deadlines, they skipped steps when everyone was in a hurry. And every so often, something important slipped through. Not because anyone was careless, but simply because they were human. The pipeline, however, does not forget. CI systems like GitLab CI, Jenkins, and GitHub Actions repeat the same steps every single time, in the same order, without stress, ego, or fatigue. Automation does not replace human judgment. Humans still decide what matters, what to test, and why it's important. What automation replaces is repetition. And repetition is exactly where humans make the most mistakes. That is how modern teams move from hoping everything works to proving it. Many teams didn't start with automation. They tried to test everything manually. They opened staging environments, clicked through screens, followed checklists, and sincerely believed they were being careful. And most of the time, they were. But they were also human. Fridays were long, deadlines were tight. People skipped steps, just this once. Rare edge cases got forgotten, simply because nobody had the energy to think about them anymore. Meanwhile, the pipeline never gets tired. CI systems like GitLab CI, Jenkins, and GitHub Actions repeat the same checks over and over again, exactly the same way every single time. They don't rush. They don't argue. They don't say, "We'll test that later." Automation does not replace human judgment. Humans still decide what matters, what to test, and what risk looks like. Automation replaces something else: repetition. And repetition is exactly the place where humans are weakest. That is how teams slowly move from hoping everything will work to proving that it does. Over time, a good pipeline starts to feel almost musical. The code is built. Right after that, the smallest checks, the unit tests, fire automatically. Once they pass, broader integration flows run to make sure services speak the same language. Then the regression suite steps in and quietly replays the most important real-world scenarios, making sure nothing old has broken while something new was added. And, in parallel, another set of eyes is always watching. Tools like SonarQube look at coverage and patterns that often lead to future bugs, almost like a second opinion saying, "Are you sure this won't bite you later?" In one company I worked with, the rules were simple, and everyone knew them. If a unit test failed, the developer stopped and fixed it right away. If an integration test failed, the first step was to talk to the teammate whose service was involved. But if a regression test failed, everything paused. The priority wasn't ego or deadlines, it was production. Users came first. Stability came first. From the outside, that discipline can look strict, but inside the team it felt like the opposite of control. It felt compassionate toward users, toward engineers, and honestly, toward everyone's sleep. I once worked with a tech lead who repeated the same sentence almost every week. He would say, "If something has to fail, let it fail where nobody gets hurt." At first, it sounded almost philosophical, but over time it made perfect sense. That is what pipelines truly give us. They create a space where experiments are allowed, where mistakes are discovered early, while they are still harmless and still easy to fix. They don't just block bad changes, they teach teams how to build safer ones. And the more problems your pipeline catches inside testing, the fewer apologies you end up giving later in production. Imagine you're in an interview and someone asks what role automated testing really plays inside CI/CD. The strongest answer isn't about listing tools, and it isn't about buzzwords. It's about responsibility. Automated tests are the quiet decision makers in the pipeline. Unit tests protect the logic itself. Integration tests protect the way systems talk to each other. Regression tests protect everything that worked before, making sure it still works today. And because the pipeline runs all of them automatically, no risky change can move forward silently. That is what production needs. Not heroism, but carefully designed safety nets that do their job every single time. By this point, something important has taken shape. Code flows through the pipeline automatically. Artifacts are reproducible. Tests watch every change and guard behavior at multiple levels. But one big question still hangs in the air. What about the environments themselves? Who creates them? Who configures them? And how do we really know that staging and production are identical instead of almost the same? Sooner or later, every engineering team reaches the same realization. If we already treat application code like code, why don't we start treating infrastructure the same way? That simple question is what leads us into the next chapter. The world of infrastructure as code and the mental model behind tools like Terraform. End of 2.2.5.